everyone, Paw here. Tired of hearing DNS is the internet's phone book? Me too. Let's jump straight to the meaty details, the stuff that matters when you're building your lab, prepping for CCNA, or just leveling up your network game. Stick around, because we're about to make DNS click in your brain once and for all. Section 1. What even is DNS? Look, you already know DNS stands for Domain Name System, translating domain names to IP addresses. Section 2. How does DNS technically work? This is where the magic happens. When you type a domain into your browser, here's what goes down. 1. Resolver. Your device asks a DNS resolver, often your router or ISP, for the IP address. 2. Cache. First, the resolver checks if it already knows the answer, cached from a recent lookup. If it does, you get a reply in milliseconds. 3. Recursive hunt. If not, the resolver goes on a quest. It first asks a root server, which doesn't have your final answer but points you to the right top-level domain, TLD, server.com.net, etc. 4th TLD server. That server directs you to the authoritative name server for the domain in question. 5. Authoritative server. This is the final boss, giving the actual IP. The resolver then brings that IP address back to you, victorious. 6. Cache. Again, this result is cached by your resolver and maybe even your browser, speeding things up next time. All this under the hood magic happens before your web page even starts rendering. Let's break down this DNS lookup using the dig command. First, we're asking for the A record. That's the IPv4 address. We're sending our query to the DNS server at Quad 1. That's Cloudflare's public DNS. If you look at the status line, you'll see status. No error. That means the query was successful and there were no issues. Next, check out the question section. This shows exactly what we asked. Now, the answer section. Here, we get back 2 IP addresses. That means the domain can resolve to either of these addresses. And notice the TTL, or time to live, for each answer. Here, it's about 2,000 seconds. That tells your computer how long it can cache this result before checking again. Section 3. Common DNS Record Types. Let's zoom in on the critical records you'll see all the time. A record, address record, maps a domain to an IPv4 address. Quad A. Same deal, but for IPv6. CNAME, canonical name. Points a domain to another domain, not an IP, perfect for aliases. PTR, pointer record. Used for reverse DNS, translating IPs back into domain names. Other types do exist, MX for mail, TXT or SRV for services. But if you nail these 4, you're golden for most real-world needs. Section 4. Hands-on, using dig in the Linux terminal. Time to get practical. If you're running a home lab, Pi-hole, or even tinkering with your DNS setup, dig is your new best friend. A basic lookup can be done by just typing dig followed by the domain you want to look up, returns the A record. To get an IPv6 record, you do dig a4 times example.com. Checking a CNAME, dig CNAME www.example.com. Reverse lookup, PTR, give you the host name of an IP, just do dig-x followed by an IP address. To query a specific DNS server, like Google's, you can use dig at 8.8.8.8 followed by the domain. Short answer with +short give you just the result. Pay special attention to the answer section. It's the juicy part showing the actual record. Section 5. Real-life scenarios. So why does all this matter? If you're messing with a home lab, Pi-hole, or Active Directory, DNS is the invisible glue. Many network engineers will confirm the pun. It's always DNS. Some example often causing problems. Split-brain DNS. This means different answers internally versus externally. Wrong local domain. For example, user connected to a VPN trying to resolve local or AD domains. PTR and email. Poorly set PTR records can get your emails flagged as spam. Do not forget the reverse DNS record if you run a mail server. Section 6. Quick tips and gotchas. DNS record changes don't always show up instantly. TTL, time to live, can keep old data cached. Often the default cache time is 1 day. DNS typically uses UDP, port 53, but can switch to TCP for big queries like DNS-SEC. Often admins make the mistake, assuming DNS equals UDP. For privacy, consider DNS over HTTPS or DNS over TLS, because default DNS queries are unencrypted clear text. Remember, caching is layered: browser, OS, resolver, finally authoritative name server. You need to make sure you're clearing the right layer when troubleshooting. Wrap up. DNS isn't just names to numbers. Under the hood, a lot is happening in a split second. Knowing how to dig deeper unlocks serious power in your lab setups and day-to-day network troubleshooting. This video was very, well, let's say on the surface, but if you want more DNS-specific stuff, drop a comment and let me know. This is Paw signing out.